Okay, let's get started. What I'm going to do is cover the second half of lecture number 6, which was on, actually, what was lecture number 6 on? J2EE, and that's the given. But I think it was on web tiering. Yes, it was. It was on no, it was on Java JSP. Last time I covered transaction management, and I covered the JTA Java Transaction API. And I went through all of that stuff, which is about halfway through this lecture. The other part is on web tiering and Java Servlet pages, which is what I'm going to cover today. So this is all in the PowerPoint lecture number 6. And I need to skip to where I left off. And this is all that was covered in the last lecture that I gave 2 weeks ago. So let's see. Oops. This is where we stopped the lecture. And I know that because I just looked at my notes on that. And this is where we're going to start today. So web tiering. This is where we get economies of scale. We get to be able to handle simultaneously multiply connected clients to one server, but they're not really all going into one server. We have an interface that they're coming into, which is usually referred to as a web server. Behind the web server, we have application servers, and we have persistent storage servers, which are like database servers. And we have file servers and media servers and all sorts of different servers. Well, they're actually really called tiers. If we tier out the interface, then we can service millions and millions and millions of clients and have all of the work distributed over multiple systems and not have to worry about holding the capacity all on one computer or all on one server. Which is why web serving and web tiering started. That's the concept in which it started out with, and that was like, wow, we can now have millions and millions, because as the internet grows, every customer who logs on to Wells Fargo or to wherever is utilizing resources, and those big companies, they have to worry about, well, how are we going to service all these customers? It's not like a mama papa homepage, on one website that somebody puts together. So you really are talking about a big business kind of concept. So a Java 2 EE application web tier makes application business logic available on this www concept. So the web tiering in terms of Java 2 EE is in relationship with what goes on each one of the different components, and the components are servers. And the servers are acting like tiers, and the tiers are serving a special purpose function for the Java 2 EE environment to orchestrate all of its activities, to distribute all the computing onto multiple different systems. And I'll talk about the tiering. I'll talk about where the components reside. And this is where servlet pages come into place, JSP, and Java beans and containers are used to orchestrate all of this stuff as well. So the web tiering by default handles all of the application communication with the web clients, and the web clients are you, or the customers, and invoking the business logic and transmitting data in response to incoming requests and all of the different things that happen behind the scenes in terms of a web application. So a server in the web tiering processes uses HTTP requests. No brainer there. The entire world wide web is on HTTP as the protocol. So it interfaces with that, which means it supports all HTTP compliant protocols such as HTML and scripting languages and all sorts of different technologies that work together. So when you work with JSP, you're working with HTML as the interface language, because just like in the old CGI days when you logged into the computer, you were a client, you logged in, your client connected to a server, went over a CGI interface, which was just nothing more than a port, open port, entered through, ran a file. Well, that file ran on the server. It was an executable file or a script or something, and the output is generated in the form of HTML. HTML is sent back through the port into using the HTTP protocol request, or send actually, sends it back out to the client. Client only speaks HTML in terms of its markup language. So we do have client-side scripting languages. Scripting languages only run from a client perspective on the client computer. Server scripts only run on the server computer. So we do have that kind of orchestration back and forth, the handshake that happens between the client and the server, all done through HTML. So just put that as a kind of a bookmark in the back of your memory that anything having to do with the client, the interface is always in HTML. It doesn't really matter what you're doing. So naturally, as you might assume, JSP works quite well with HTML. So does ASP. So does all of the other servlet technologies that are out there because they have to. It's the way we're going to get content to the web browser. It doesn't actually have to, however. Outside of the web browser environment, there's a ton of applications out there that are internet aware that are running scripts on servers and scripts on client scripts and things that are embedded into applications. As an example, any program that updates itself isn't giving you HTML code. You know, it's not, because there's no web browser interface to that. It just goes out and finds, hey, there's a new update. You know, would you like to get it right now? It's kind of like how Firefox updates itself. That's a client server application done through HTTP, but it's faceless. It doesn't have an interface. So the the Java 2 EE platform, the web tiering itself, usually manages the interaction between the web clients and the business logic. So the web tier is the front end, and that's what we usually refer to as the entire application, although it's just handling the connections to the clients. It produces HTML, so the web tier typically stores all of the HTML documents. So because it's the front face and it's what the client is actually accepting in terms of its output. Also XML content as well. XML content, there are some browser aware plugins that can, like, you know, in fact I think Firefox supports, and it'll actually just show you the XML code, but it won't do anything for you because XML doesn't really run on the client. It can if you have an XML interpreter, but it usually runs on the server instead of the client. I talked about XML, I believe, 2 weeks ago in terms of how you write it, and showed you a little XML example of tags, and it's a just to refresh your memory because this lecture sort of continues on the same concept. It's a markup language for data, not presentation, so it doesn't show the client anything. Instead, it marks the data. This is the first name, this is the last name, this is the social security number. Hopefully you're not taking that over the internet. But long story short, it's used for databases, used for, you know, it doesn't have to be a database, it could be a text file, it could be something where you're generating information about the client onto the server. XML was the great solution that solved all of the problems with, well, not all of the problems, but it was a nice workaround for the getting rid of cookies, actually. Because you can have the information go back and forth, and you can send it, you know, from client to server, server to client. It works both ways, and you can pass data all in one chunk, and the data can be parsed, interpreted, read, and processed, and you know, you don't necessarily have to store it, you know, in a text file on the client's computer, which is that cookie file. So cookies were like the, you know, pre-low-tech way of storing data. If you're not familiar with the concept, because most people don't work with cookies because the virus programs remove them now anyway. But you get a website, you have some parameters, some properties set for the interface or something, the look and feel. Or maybe it's a purchase history, or maybe it's your name and telephone number and stuff like that. Well, in the application or in the web page, you can design it. In the old days, this is what people did, so that it wrote all that stuff to a text file and stored it in the directories for your web browser. And then every time you return back to that page, it would read the text file and then populate the page with all of the information. Now they store it in sessions, so we have session data that we keep on clients. And instead of storing it on the client computer, we store it on the server. So the server still knows about you. It's to keep that kind of dynamic environment in or a connection-oriented look and feel from a connection-less environment. Because once the client goes away, without any saving of any of that information, you know, you come back in, you have to go set your parameters all over again. You know, you won't have anything saved. So it was a great way of keeping and creating a great user experience. Unfortunately, people abused that. So in fact, people are abusing XML right now too, which is kind of sad. You know, every good technology that gets out, somebody has to find a way of messing it up. So, in fact, you can write your own, and this is what the problem, you can write your own XML interpreter. So now you can impersonate other websites, have your own XML interpreter to take the information, process it, you know, spoof information from other places that are taking XML information, parse it, write your own parser, which is kind of easy actually. Parse the information out of the sheet and process it to your own desire. Accumulate lists of credit cards, and hopefully you're not putting credit card information out on the internet in a non-encrypted format. So what you don't want is all that information to be flying over anyone to go grab and interpret themselves. So, which is nobody does that anymore. Now we have secured channels. Now we have encrypted, hopefully, messages and stuff like that. Encrypted information. But for every encryption, there's a decryption. So, but not to scare you, a lot of traffic is spoofed these days, and even websites themselves are spoofed. So it's no time before XML gets a bad reputation as well. So, but XML is a basis for a lot of stuff right now, and so there's a lot of people keeping it safe and secure and using it only for particular purposes. So I mean, it can be used just like XML. I mean, HTML. The only problem is, people send documents. It started out as document exchange. So you send invoices to companies in an XML format. It left one computer, went to another computer, and then it was, parsed and interpreted, and then the invoice was generated. Well, you just intercept that message like any other message you can intercept and parse it. It's easy. It's all in text. The information's out there. So it does have some vulnerabilities, let's just say, in terms of problems. But this isn't a security course, so we're not going to get into networking security. I think there's an instructor here that does teach a security course. Not a bad option. All right, so while business logic is often implemented as enterprise beans, it may also be implemented entirely in the web tier. You don't have to separate everything out. We do have this kind of format, and I call it a design pattern. It's a web tiering design pattern that's put into place to make the best use of the components that are part of this architecture. But you don't have to do it all this way. You can have pieces of it. You can actually have multiple components residing on one server or one tier, which is kind of common, especially when a business is just starting to grow. Who's going to go out there and buy a bunch of equipment? And who's going to set up a whole tiered system for a company with 5 employees, right? So you're not going to, or 5 customers or something. Hopefully you're not going to branch out too quickly. In terms of the web tier functions, and I'm starting out with the web tier, which is the front interface to the application. As I mentioned in the previous slide, it holds all of the XML and the HTML documents and the interfaces. So the parsers and things are all on that web tier. And it's web-enabled business logic. So we have the web tier that manages the interaction between the web clients and the application business logic. What does that mean? It's kind of like a main menu in a program. The main menu sends a customer to option number 1, option number 2, option number 3. That's what the web tier does. You log into the web tier, you get the HTML, XML interface. This is, would you like option number 1, option number 2, option number 3? And let's say it's a Wells Fargo customer logging into the Wells Fargo web tier, or I just say I don't like to say bank names and things. The Bank X out there, and Bank X has a couple of different applications residing. You can check your account, work with your account. You can do financial services as an example. You can get a car loan or something like that. So each one of those separate applications might be stored on different servers, and they're probably going to be all in the application tier, which is going to be behind the web tier, but they're going to be routed from the web tier. So the web tier controls the main routing to the business logic. So if the customer has indicated that they're interested in a car loan, they're going to go a different route. And the web tier's responsibility is to route it, sort of like the main menu of a program, if you think about it that way, which is kind of the purpose it's serving. When you write a program, you have some sort of a navigational system. In the model view controller, they call it the control. There's some sort of way that this program is being controlled and navigated. So that's the web tier in the J2EE environment. So it also generates dynamic content as well. So the web tier components generate the dynamic content, including the HTML, the images, the sound, the video. So that's where you get your, your open HTTP protocol that comes into the public area of the web tier that is storing and housing all of the components that are giving you that dynamic behavior. The logo that shows up, the menu on the screen, all of the scripts and things that run the menu. So it presents data and collects input. Yeah, the web tier is doing all of the input of all of the data. If it doesn't get through the web tier, doesn't go into the web tier, it's not going to make it to the application server. So if someone did try to hack in, let's say, to the application tier, they bypassed the web tier completely and tried to get in, it's really hard to actually access anything without the right input, without the right configuration preset before you get there. Done twofold. First reason why is the web tier has those components on it, installed on it for HTTP. Your application server may not necessarily have anything HTTP oriented on it, and probably doesn't even have the ability to be connected to from an HTTP interface, which means you can't get to it through the internet. So it's safe. You know, let the web tier be the front end. It's kind of, okay, going back to a military example, it's sort of like the front line. Let those people out there take the force of everybody coming at them, and then the people behind them are the business logic and the applications. And these guys out here, not to say that, you know, I'm talking about soldiers, not to say that the front line is worthless or anything, but all those people generally get killed. You know, do you really want to put your executives and your managers and everybody else up front? Now you build up a force up front to take the brute force of everything that's coming at them. That's the web tier. You put all the important stuff behind it and keep it safe, so it's not going to get attacked, not going to die back behind the front line, and lives longer, provides better security, and you can put more critical data back there. You know, you're not going to put your critical data on a web tier. Otherwise, it's going to be stolen eventually. It's going to get lost, stolen. Something's going to happen to it, hacked into. So hackers go into web tiers by first entry. Well, it depends on the type of hacking that you're doing, but that's the easiest form to do. So it generates the dynamic content, it presents the data and collects the input, so the components translates into HTTP put and get actions. When you take web development, this is where you're focusing on. You're focusing on web tier applications, because the web tiers are the presentation, content to the client, the puts, the gets, the actions to make the business logic work, and understands and presents the web content. So it, not to say that there is no preference or no priority in terms of the criticality of any of these tiers, however. It takes just as much work to put together a web tier than it does an application tier than it does anything else. And there's no implied impression that the web tier is worthless because it is the front line, or, you know, just the same way as the soldiers aren't worthless either. They're people, they're humans just like everybody else. Well, these are servers just like everybody other server in the system. So it's just as important to keep that up, because if that goes down, then you are possibly opening up vulnerabilities and weaknesses into the rest of the system, which you don't want. So a lot of protection, a lot of control is put on that web server to keep it alive. So we don't keep, it's just like the government, we don't want to lose all of our soldiers, so let's support them and support their needs so that we can, keep them out there. So. It also controls the screen flow and the access. It acts as the gatekeeper or the traffic guard. So the logic that determines which screen, as which page is going to be displayed next, usually resides on the web tier. Because the screen flow tends to be specific to the client capabilities, obviously. If you are a mobile client and you go into the web tier, it should know that, and it should figure that out, and present you with content that's related to the mobile interface. And all of the things that you can do are for the mobile. If you're on a computer out connecting through the World Wide Web, you have different features. If you're corporate, in-house, you have different features. So the web tier is responsible for that. Maintains state as well. So it has simple, flexible mechanism for accumulating data and transactions, interactions, and content over the life of the session. As I mentioned before, servers deal with sessions, and sessions are server data, which is the opposite of cookies. So cookies were the invention for the client, not really good. So sessions, Here's the replacement, one of the big replacements in terms of the concept. Put it on the server. So it's really the equivalent. It's just information that's being stored. Not really. Actually, it does get stored in log files, but it's mostly persistent data that's being stored about users. So supports multiple functions and future client types. It has its own crystal ball. No, it's extendable. So we have extendable MIME types that describe web content so that the web can support any current and future type of downloadable content. Makes the system flexible. It's like in the old days when we wrote programs in C or C++. You're like, the old days? I just took that class. Yeah. We still write programs in C or C++, but if you wanted to take that program and put it on a Mac, you gotta recompile it. Put it on a Unix box, you gotta recompile it. Put it back on Windows, recompile it. WebTier is multi-platformed and supports multi-connected different types of clients and creates a kind of an environment where the user interface look and feel is portable on the web tier. It is not portable anywhere else. So, but if everything's going through the web tier, then you can design that as a feature of the web tier so that mobile clients have a mobile client experience, desktop clients have a desktop client experience, going back to that example. If you put it on the web tier and you use the web tier as your front end into the tiering, there's no need to consider anything else anywhere else. You don't need it. If everyone's going through the web tier is controlling that. So part of the tiering process is to delegate responsibilities for different components of the system. So anything user interface oriented, anything portability, anything supporting clients is on the web tier. Many implementations might implement some business logic. Kind of risky. If you're a small business, you're going to put the business logic on the web tier as well, because you're not going to want to move it off anywhere else. Plus, sometimes it logically belongs there. So, many enterprise applications implement business logic and enterprise beans, and I'll talk about that in a few minutes and how that works. Web only, low to medium volume applications, small applications, simple transactional behavior can implement that business logic entirely on the web tier. What does that mean? Now, to put it into terms you guys are probably familiar with, it's writing a PHP script, putting it on the web tier to connect to the database. Why would you want to create a Java bean, put it in a web bean container on an application or a bean server, connect it for the connection to the database that's going to be called from the web server and all that stuff I talked about last time in terms of all the beans and separating everything out. Why are you going to do that for a simple little application servicing 100 or 200 or so clients? The trick is to put it on the web server, take and create a server-side script using PHP, Python, Perl, scripting language of your choice, stick it on the web tier. Those are web tier scripting languages, by the way, which is interesting. When you take web development, you're learning web tier technologies. Web tier technologies are, I'm going to use my fingers to quote here, scripting languages for the most part. PHP, Python, Perl, I don't know, I could probably come up with a couple new ones out there, maybe some experimental stuff that's going on. All that stuff is done on web tier, which is why they call it a web scripting. And it's not part of, but it's used in conjunction with Java 2 EE. Doesn't mean you can't use PHP. If you're going to put a business logic on the web tier, you're going to use a scripting language, a web scripting language. If you're going to go past the web tier, you're going to use Java Beans, or you're going to use another ASP component or something if you're working on a Microsoft system that goes past the web tier. We don't put PHP, Python, Perl on an application server. That's web tier technologies. So we put Java, C++, other languages, any language you want, actually, because it's not running on the internet. It's a traditional programming environment, Fortran, COBOL. In fact, most banking systems these days that have web interfaces to them have old servers with COBOL and Fortran, and there's people still developing in COBOL right now on old banking systems that we know if it's not broken, don't fix it. Plus, how are you going to take all that data and you're not going to turn it all off and then transfer it over to another system? Why? And it's secure and it's already been running for years the same way. Don't touch it. But now you can log in through a web tier and get to that business logic without having to use, modern day, not modern day scripting languages or whatever. You can't put that on the application server anyway. So it's different. And then plus you take that application server, and there's also the company server. So you're at the company website, and this is the other interesting thing is until you work for a big company that has all this configured. Smaller companies aren't going to do this. And you go into work in the office, you're on the intranet. you go home and you're on the internet, but you can still access the same server. Usually, if the company's going to do that, and they're going to give you access to that application server, you're going to get an RSA key, or you're going to get some high-level security access to that server, because they're not putting it on the web tier. They're not connecting that, and you're not going into that server from the web tier, which is totally insecure. So instead, you're going to have remote access to it via some security technique, such as a key, encryption key or something, and that's where the companies get real fancy. They come up with these cards and the tokens and all this stuff. So you can be an employee and you can connect at work, and you go home, you can still connect. So you can take your work home with you, but you're not going through the World Wide Web. You're not going through, and it's interesting that some companies, they take shortcuts, and then they end up, all of our financial information is now well known to the company, well known to the world, because we decided to take shortcuts. We put it all on the web tier, all of our applications, everything is out there. We're using scripting languages to go in there and update student accounts or customer accounts at the bank or whatever. And now it's exposed. So part of security and design of securing the system is to tier it and then provide only certain access, no direct web access to the application server, and no access to that business, to the persistent data. Your database is the life of the company. That's under a vault with a double locks on it. So it's only accessible via the application server. So you can't RSA into it, a key token interface into that. You can't log into the database. Normally, you should not be able to log into a database like that. It's off under lock and key, and it's only accessible through the application server. Outside of the company, let me say, outside. Usually inside of the company, on site, full access, because you need to use it. One of the business people use, write applications, use SAP, use all a bunch of stuff on to, applications internally. No problem, you're at the company site. It's just those people that leave work. So, it would be nice if you never left work. Then you wouldn't have to ever worry about security on a network. All right, so in terms of traditional web technologies, earlier versions relied upon HTTP servers to serve static HTML pages. We all know about that through browsers. Quickly became clear that dynamic content's needed to generate content on demand. That's where the scripting languages came into place, actually. I kind of talked ahead of this slide, but this is the reasoning from a traditional point of view why we have server scripts. Then all those web server scripts are web tier designed to provide dynamic content for web interaction with clients. Mechanisms were developed web servers to generate content, web server functionality. I've already talked about CGI in this class, so I will skip through this at the speed of light because we've seen this stuff already. Just remember that there is still a place for CGI in today's economy, in today's world, because lo and behold, there's still companies that are using old databases and old scripts and old languages and things, and CGI is more compatible with that than it is to go ahead and rewrite your application in Java or to something else. And if you're not using a similar Java 2EE kind of technology, you're probably using something that's equivalent to a CGI type of interface. It's slide number 49. If you download it and read through it on your own. I've already covered it several times in this class, so I won't repeat it again. But let's move on to something a little bit different, and here's where the new stuff starts. So, modern day web tiering. So, in terms of the technologies and what's supported on the J2EE platform, this is the enterprise part of the enterprise edition. And what we're looking at is providing the benefit of server-side scripting, so we still got that, using a compiled Java class in a standardized, secure, and vendor-neutral environment. because Java prides itself on, and it does actually provide multi-vendor support. So as an example, you can use Oracle and Java are one and the same now, but in the old days you could use an Oracle database with Java. And you can use Informix, you can use MySQL, you can use anything that's not Microsoft oriented, or Microsoft server, so specific. With Java, no problem. It connects with all sorts of different types and uses drivers and things from all different vendors and supports an open source language. So a web application is a collection of web-tiered components, content, configuration, information, etc. and so forth, and operates on a single functional unit called the web server, or the web application. And the runtime support for the environment of a web application is called the web container. So from the Java perspective, everything is containerized. There we go, just say it that way. Compartmentalized. I don't know, can't say that word. In compartments, containers, that separate out the logic, and then the containers talk to each other. And I talked a lot about that last lecture 2 weeks ago, if you remember. The web application archive, the .war file, W-A-R, contains all the classes, resources, application data, along with XML deployment descriptors we've seen. So it went over that last time. That configures the application. So XML is used as a configuration tool to configure the data that's needed for the application, to set components for the properties in the environment. The .war file is kind of like a zip file if you think about it. It's compressed. It puts all the stuff all together. Because anyone who's ever written a Java application knows you got tons of different .class files. Everything's in a .class file. And you can do it actually. You can take and create an application, don't put it in a .war file. Take those take 25 different .class files, upload them, set the properties correctly. Kind of like setting up HTML websites. You know, how many pages do you have on a full website? Well, probably more like half a dozen of them or so, or at least a couple of dozen of them. You know, that's the hard part of deploying a website, is making sure you uploaded everything to the proper server and everything's in the right directory and everything's got the right permissions and stuff set to it. Simplified version is the .war file, which basically compresses everything and puts all together into one, and now that's the application, and you run the application. It's not like running a website, it's like running an application. So the platform specifications define the contract between the web container and the web components, defining the component's life cycle, how long it can be in existence, the behavior, the interfaces. Very similar to what we saw with RMI. So with RMI we've got a register, and the register keeps track of, and then we have an interface that gets loaded, and the register looks at the interface and says, hey, we have this public method, we got that public method. This is what we're making available. So when a client comes in, here we got 2 methods for you. Although the object might have 10 methods, it's in the interface is only defined 2 of them that can be used. And maybe another application comes in with a different interface and says, well, we're using the same object, but that application that's coming through has got 5 methods instead of just 2. And the interface is the contract that defines what the server is going to allow the client to access from the module or from the object. That's how RMI works, because we have remote methods that are invoked on objects that reside on a different server. Client logs into it, checks with the register, hey, what's going on here? Register has this contract. Oh, let me pull up your contract in the interface file. It says, oh, well, we have 2 methods that you can run. Which one are you running? And the client says, I want to run that one. And it goes on and runs the method, which is essentially how this is working as well. It's all based on the same foundation. It's all written by Java. I mean, it's all kind of the same house. But it's a different configuration. So instead of, by definition, RMI, and you should know this by now, remote objects. We're invoking methods on remote objects. That's all we have. It's simple. And now you're thinking, I didn't think it was simple. Well, at this point, you should probably start thinking it's simple compared to what you're going to see in the next couple slides, because you just have remote objects, and you have clients that connect to them. And you go through a register, which is a traffic cop that keeps track of them. All right, now you've got servlets with beans and remote objects all put together. So, because everything, by concept, everything here is a remote object. So we have a very similar kind of technology going on with more features. So platform specific also defines two types of web component technologies, and here we go. We have servlets, and then we have Java Server pages, or JSP pages, in terms of that technology. Most people think that ASP, which is the Microsoft version of JSP, and if you're familiar with ASP, you've got to jump on this entire game here because you already know what this is doing. It's giving you a programming language, what Visual Basic, in with a web development language. If you download, install Visual Studio, you get Visual Basic, or actually depends on what you purchase. Visual Basic, you know, C++, C#, all these, and then lo and behold, you got this thing called ASP in there. And then you go, well, what's an ASP application? Well, you can write Visual Basic, C++, you know, you could actually, it's primarily used with VB, but VB.net actually. But you can use a programming language, Microsoft House, with a scripting / web development language and create an ASP application. You type in on the web browser such and such my homepage.asp, and it's running an ASP page. Well, it's kind of like how you type in my homepage.jsp. It works the same way, except for this is written in Java, not Visual Studio, not Visual Basic, not the source code itself is written on the other side of the fence. And it does pretty much accomplish the same task. So if you've ever gotten any exposure to ASP, and I'm not going to show that in this class because this is the Java EE class, we should probably teach an ASP class here. I don't know if we do or not. That might be a fun one to teach. Although the software is kind of expensive, but as students you should get free copies of it or something, I don't know. Anyway, long story short, a servlet. Let's talk about servlet and pages. A servlet is a Java class that extends the server. Servlet's a small Java server. Produces dynamic content in response to requests from the server. JSP pages are compiled on the server and turned into servlet components. Just the same way as ASP pages get compiled on the .NET platform and then turned into .NET components. So, the server processes server requests to the servlets through the standard interface, which is this class here, the Java X. So you import the Java X servlet for every servlet that implements a servlet, so that it's supposed to create a servlet. The JSP page is the HTML page with the special markup that provides customizable behavior for generation of dynamic content at runtime. It's also usually translated into servlets when deployed. So why do we have to take and create JSP? Because we don't actually have to. We can have servlets that are created. And just think it's all written in Java. They're just small Java programs extending, importing servlet as a package so we can implement servlet technology on the server instead of running it on a local computer. Same programming source code, however. How are you gonna put HTML content out to the user through a Java program? That's where the JSP component comes into place. That's where the ASP component comes into place. So ASP gives you the website. It gives you the HTML code that the user sees. That's what JSP does. And it collects data from the user. And it delivers functionality dynamically to the user. But it's a markup language used with HTML to provide the presentation to the servlet. But the page can turn into the servlet. So you can use JSP, you can use servlets, and you can use them both together. The assignment that you're going to do for this class is going to use both. You're going to have a JSP page that's going to be hello world, or password checker I think it is. It's going to read data from an it's actually going to work with three. It's going to have an HTML page, a JSP page, and a servlet component, you know, .java file that you're going to write. And HTML is going to say, hello user, would you like to log in? Press this button. You know, simple form. You press the button. The action takes you to runs the JSP. It says, what's your username? What's your password? Gets all that stuff. Sends it over to the server. The JSP connects and talks with, because it gets compiled on the server. And it becomes the interface to the Java file, the .class file that's out there, that servlet file. And the servlet file says, here's your name, here's your password. And it says, oh, well, you're not in the system. Generates a response through the JSP as the kind of the runner in between the two, sends it back to the HTML and populates it out on the page and says, hey, you know what? That's a bad name. That's a bad password. And what you've got are multiple components that are providing that seamless kind of interaction. HTML page, JSP page is on the web server. The servlet is on the application server. So you can't get to that servlet functionality, all that stuff I bored you with 20 minutes ago or so, all that security issues. You can't. There's no harm in that applet. Actually, it's sort of like an applet. It's a very small program. There's no access to that. Only through the JSP is there access to that. So you can't just get into it. Can't hack into it. So JSP technology provides the document-centric rather than the programmatic way to specify the dynamic content generation. So it's document-centric, which means it works with the HTML. Each HTML page or interface is going to have its own JSP, and JSP is a scripting language, not a well, I shouldn't say that. It does get compiled, but you'll never see or run the code that way. You run it as a text page. It's a script. It's written in text. It's running like ASP or like PHP or any web tiering scripting language. It runs the same way because it's also a web tiering scripting language. So the application runs inside of the server's web container. Container manages the life cycle. It dispatches the service request to the application components. Those are those beans that are over there on the server, in the application server. And you actually kind of just, although this seems like a, the terminology is like embedded into this into this slide, because you're talking about a web container that's requesting application components, which is telling you what. Basically I said with the runner, the JSP, which is the web component, who is accessing the application components through this interface. So it's a script that's connecting the glue, that's patching everything together. Provides a standard interface for the context of the data, session states, information about the current requests, all sorts of different information comes into this. The web container provides the consistent interface. Yes, we know that, hopefully by this point. HTML is the persistent, consistent interface. Hosts the pages to the client. The web components are portable across application servers, which means just because you ran this once, that scenario I just went through with Hello World and the password program, all you have to do is configure the web servers to go to different application servers, and voila, you've moved the application over to a different location. So if all the pieces are intercomponents and they're just connecting to each other, it doesn't matter where they are. One server goes down, well then just switch it to the other one. You have multiple replicated servers or something, so you can, or let's say you have a lot of clients asking for passwords. So you can have 5 different web servers, application servers that are all doing the same thing. Then you would have Google, because they don't have just one server. When you go google.com or whatever, you're going into like a server farm. You're going into like several, and they're distributed all over the United States. They're not all in one area either, because then you could really have a distributed environment. But you have multiple application servers, multiple data servers, multiple everything that are all functioning the same way, doing load balancing. So you can have 5,000 people logged in simultaneously, or 5 million people, and the client's not going to know the difference, and the company can support all the traffic. So, biggest problem with most companies is they find, after the 10,000 customer logged in, and then customers go, how come it runs so slowly? And then they understand that, oh, there's something wrong with our tiering. We're not built to scale correctly. So then you change the infrastructure to tier it, and then you start scaling it, and then as your company grows to 10 million customers, hopefully, then you have 5 servers, 6 servers, 7 servers, or whatever, and you can actually kind of see the impact, and you can do network statistics on bandwidth, and you can do all sorts of different comparisons to see, well, which is the better combination and the most cost-effective combination. The bigger your company is, the more expensive your servers are, because you have to support all of their needs. Okay, so Web tiering provides the consistent interface. Packaging and deployment of those web applications are standardized. We've got that web application that can be deployed into the servlet without recompiling the code or rebuilding the application archive. So just like, as an example, as I was mentioning before, just like in the RMI component where we've got that remote object and an instance of that object is made and everyone is contacting the instance of that object, servlet components work the same way. So you have the JSP, it's compiled, well, pre-compiled. The servlet loads up, all of those things are loaded automatically. We're only going to one instance of all of those things. Now each client doesn't get their own instance of the bean that's connecting to the database. So we have economies of scale where we're servicing multiple clients with the same instances. So it's using that kind of same concept. And it's pre-compiled, which means it runs faster. So in a CGI application, as a kind of a classic example here, in comparing the two, the CGI program gets run when you connect to that server. It's not anything, regardless of how many other clients have connected to it in the past and who have also started and executed that program as a process on that server. Each client is unaware of what everybody else is doing, and each client invokes their own instance of that object. So in a non-CGI environment, you've got the economies of scale built in for you automatically. So the Java Servlet is the Java class that extends the Java 2EE compatible web server. Think of them as Java classes that can dynamically, that can generate dynamic HTML content using print statements. Kind of like how the Perl program in CGI generates a print statement that sends a command out and translates that into HTML code, or actually it prints out HTML code is what it does. So, in fact, you can do this on your own. In fact, it might actually be a fun exercise if you've never done this before and you're a computer science student. You have access to a server and you have CGI module installed into the server. Create a CGI bin directory. Write a C++ program, hello world, that prints out, HTTP compatible HTML code, and go to your web browser and type in a page that's gonna, or like maybe create a JavaScript or something that goes in and runs that. It's not very secure as an application, by the way. And you'll see you can actually run a program on the server from your web browser, which is actually kind of cool. Which, if you have technology installed on your system or have access to it, running that CGI example might actually be kind of interesting. And running the servlet example might actually be a good experience as well for you, because then you can kind of see the servlet stuff work. So, similar to CGI, servlets support the requests and the response programming module. But here's where we kind of differ a little bit. Servlets offer some important benefits over earlier dynamically generated technologies. Also, this is basically comparing servlets with CGI as a platform. Servlets are compiled Java classes, so they're generally faster than CGI programs or server-side scripts, which is kind of interesting, because if it's a compiled program, you've got all the benefits of running a program versus a script as well. But it does run faster because it's using the memory on the server, not the memory in a scripting engine. So, which scripts will generally run slower than a compiled program in comparison. Only because scripts have to be processed when they're being run. And compiled programs are pre-processed. They're statically bound. Everything is already set ahead of time. Servlets are safer than extension libraries because the Java virtual machine can recover from the servlet that exits unexpectedly. The JVM controls garbage collects. So we've got security features of Java built into the servlet environment as well. We have all the benefits of the regular old JVM that you're running on your computer. Servlets are portable, both at the source code level because the Java Servlet specifications, and at the binary level because of the innate portability of the Java bytecode. So you can take it and run it on different servers, different breeds of your servers that you're working with, and they're all going to be compatible because they're all written in Java, just the same way as you can deploy the same application on different platforms, PC platforms. Servlets also provide a richer set of standard services than the widely adopted server technologies. There's more functionality. in a servlet than there is in an old program that you could write and run through CGI. So the JSP, the Java Servlet pages technology, abstracts the servlets to a higher level, directly competes with Microsoft Active Service pages, as I mentioned before. ASP and JSP are accomplishing the same thing, the same technologies. But you can't run JSP on a Microsoft server, and you can't run ASP on a non-Microsoft server. So you draw the line down the middle, and you decide, am I going Microsoft or am I going not Microsoft? And then you decide which route of the technologies you're going to do. And a JSP page is a document containing fixed template text plus special markup and for including other text and executing embedded logic. So we've got text plus we've got script / commands and things of that nature that are embedded in there. Fixed template text is always served to the requester. Just as it appears on the page like traditional HTML, that would be fixed markings and things, XML or HTML. Compatible with both, actually. Special markup comes in tags. The markups can take one of 3 forms: directives, scripting elements, or custom tags. So think of JSP as an inside-out servlet. Because you're taking the servlet and you're providing all of the interface to it. So it's the inside interface that's coming to the outside that you're seeing from the server functionality. So it's kind of an inside-out servlet from the kind of a abstract, kind of point of view. And because you have different components and different functionalities of that page, that's why you have the different forms. So the markup comes in, are you marking up scripting elements? Are you marking up tags? Is it HTML? Is it XML? Is it scripting related? So that's why you have those three different forms of marks, notations, I should just call it that, or tags, or markups that you can put in the page itself. You'll see that when you run that assignment, actually. And the assignment is not as hard as you think. It actually is a tutorial assignment. It runs you through all the steps. So you don't really have to know any programming to actually do it. So JSP benefits, pages themselves, the benefits of using JSP. So it easily combines static templates, XML, HTML fragments with code that generates dynamic content. Imagine, just like an ASP, where you have Visual Basic, HTML, and XML, JSP has got Java, XML, and HTML. So, same concept. Pages themselves are compiled, so the Java stuff is going to be compiled at the servlet when the request is made. So the page authors can easily make update presentation code that can be precompiled if desired, but it also can be done dynamically. So if you're going to work in an environment for which the page itself might change and you're going to be doing some updates to it, instead of embedding it all into the servlet component, you separate out the interface to it, put it in a JSP page. JSP page, just like HTML pages, can be modified daily. You just copy the new page into the directory, just like you update an HTML page. So you have that benefit of being, and here's the other thing too, you have the benefit of non-developers working with this. So as an example, you hired an artist who doesn't have any programming skills, but he or she is an excellent graphic designer and and hopefully you're doing this if you're in a company. You're not going to hire a programmer to do your UI because they don't think like graphic designers. So you get someone with some talent who is going to create, some gorgeous interface to your company, and that person can edit a JSP page, no problem. Can they write Java source code? Probably not. So it makes it so that it's more user-friendly for non-developers to actually work with and to update. Plus, if he or she wants to go in and change something, change the logo, change the colors, easy. Don't have to go ask and bug the programmers, hey, can you recompile this? So JSP lends itself, if you're going to use this technique, out to make a team effort more usable, more user-friendly, because team people can work with stuff without having to bother everybody else. And then JSP tags are also included for invoking Java Bean components that manage three components completely. So JSP tags for invoking Java Bean components manage them, and they shield the page author and the complexity of the application logic. So It makes it so that you can call bean technology from the JSP. You can basically invoke all of the capabilities of the application server. Developers can offer customized JSP tags and libraries. It's XML. You can customize everything, actually. It's similar to XML, but the JSP itself can be customized. And the pages have all the benefits of Java technology, including the robust memory management and security and all the other features that go along with it, and provides enterprise-class scalability and performance. So you can create more pages and more pages and more pages and really scale it. So there's also some speed improvements when using JSP. So separating out the content generation from the presentation is another theory involved with this. So using JSP technology, web page developers use HTML or XML tags to define and format the results page. So if the core logic is encapsulated in tags and beans, then other individuals, such as webmasters, as I mentioned before, and page designers can edit those pages and not have to worry about it. So that's, the formal definition for what I gave you a few minutes ago with hiring those designers instead of the programmers to work on your UI. So they're editing JSP pages. Doesn't matter what they do to the JSP page. They're not going to break the functionality that's compiled into the servlet components or the bean components. In fact, you're shielding. You're providing protection. If you have everything in a website, and you have all the business logic in the website, and you have developers working on this, and you hire a graphic designer who has absolutely no background in programming, and he or she makes a mistake, your whole entire website is probably going to be corrupted. And the logic of that website is probably going to be messed up after a while. If you separate all that stuff out and protect the core functionality and put it into Java modules and separate out the abstraction, it makes it easier for those people to actually do their jobs. Because then you can edit a JSP page, edit HTML pages, and not only do you have more control over what you're doing, you can't mess it up. You can't mess up the business logic at all. So, emphasizing reusable components as well, another kind of feature of this. Most of the JSP pages rely on reusable cross-platform components or enterprise Java beans. So to perform more complex processing required for the application. And developers can share and exchange components. In fact, there's a ton of them out there for all sorts of different web activities to perform common operations or make them available to larger users or customer communities or all sorts of different things. So third parties can make Java beans and technologies, and then everybody else can use them or buy them or open source them or whatever. And component-based approaches speed up overall development, obviously, and lets organizations leverage their enterprise environment. So, in fact, we're using that at ITU, actually. We're using third-party components in the development of both the website and also, everybody does. The LMS actually is using third-party components. So who's gonna rewrite it yourself? So if you can make use of existing technologies and components, and you're just designing an interface that's connecting to those components, then you have the logic already pre-built for you. You just decide, well, how are we going to implement it and how are we going to use it, kind of thing. So, specifying page development with tags as well. Web page developers are not always programmers familiar with the scripting languages or programming languages themselves. So the JSP technology encapsulates some of the functionality required for dynamic content generation to easy-to-use XML tags. So if you create the commands that are actually going to produce the desired functionality that the Java components need to use for its implementation, you can create your own customized tag library where developers can say, this is the username, and if it defines a username, the tag is already translated automatically for them. They don't actually have to implement that logic. So the tags that are being created for the designer to implement, to use, are performing the necessary steps needed to make the functionality work. So standard JSP tags can access and initialize Java Bean components, set and retrieve Bean attributes, download applets, perform other functions and otherwise more difficult and time-consuming to code behaviors that the web developer doesn't have to worry about. So the technology is extendable through development of customized tag libraries, which is where we get the power in here. So So every time, VerTime, that's interesting. VerTime, third party, I need some editing here, developers. So we'll create their own, okay, so developers will create their own tag libraries for common functionality, so that it's kind of like creating a function in JavaScript or something, but it's done in the JSP XML format. Create a tag if you're going to always be taking a username and password or something like that. That's why page developers work with more familiar tools and constructs such as tags to perform sophisticated tasks. Here's the big picture, and this is a simple, and this is the one you'll be doing in your assignment, but you won't be connecting to a JDBC database. But you could easily translate that into some sort of a connection. So the model basically replaces the CGI bin concept with a JSP page. So we have a browser, has an HTML interface to it with XML, running over, and this is the protocol being used, HTTP protocol, that's going from a browser to a JSP page. And JSP page.jsp is invoking a method, a bean perhaps, or it's just invoking a method. And the method is going to go use JDBC, as we've seen so far earlier in the course, and connect to the database over here. And voila, not very secure, not tiered, but it works. It's very simple. I'm going to take this and like bump it up a couple of steps, add some more components to it, functionality. But the model has following advantages. It's simple, fast to program. This is what you're doing for your assignment, actually. You're not going to do anything too sophisticated. And the page author can easily generate dynamic content over here. And based on the request of the state of the resources. And architecture works well for many different applications, but it does not scale well for a large number of simultaneously web-based clients accessing scarce enterprise resources, since each must establish or share a connection to the component resource that it needs to access. Every single client who logs into this system with this very simple example is going to take up this HTML page, run this JSP script, and make their own connection to the JDBC database. This is as bad as CGI, and it does not take advantage of any of the Java 2 EE platform capabilities. So even if you installed and paid the money and did everything, well, surely Java's free, you don't have to pay any money. So you have to buy the equipment to put it on. But long story short, you can still accomplish CGI. This is equivalent to CGI. Replaces CGI in concept, but it's equivalent in terms of efficiency. Every single client is having their own instance of the object created, and they're using their own data. And here's the problem, here's the bottleneck right here. This is going to stay the same, but here's the bottleneck right here. We've got everybody's invoking a method for JDBC. You don't want to do that. That's way too time consuming. So as an example, if the JSP page accesses a database, it may generate many connections to the database, which can affect the database performance. So we tier it one more level. So a flexible application with servlets, and this is where this does not use a servlet, by the way. This is using a JSP page that's connecting, and this happens all the time. This is the average way of doing something. And it's just a JSP replacement for CGI bin. If you're going to do this, you might as well just use CGI. You're going to have the same features and same capabilities. So you add the servlet. The servlet's the go-between. What is the servlet going to do? In a nutshell, I'm going to talk ahead for the next 5 slides. Just give you the big picture. I'm going to put a bean out here. Bean out here is going to, so we're going to put something in here, in between. So the JSP page comes out to the servlet environment, finds the Java bean that's managing this resource. The bean's going to serve up all of the requests to this resource. You only have one connection to the bean per client. So you have multiple connections to the bean. However, you're not bogging down this resource. Instead, you've got one connection from the bean to the Java server. The bean's managing the resource. And if the bean can manage the resource, you can use the resource more efficiently. This we can tier off. This we can make, well, if we have too many simultaneous clients connecting to that bean, no problem, create multiple beans. Create another bean. Put another bean out there. And if you separate the beans out, so one bean is a resource bean, we have different types of beans, and I'm going to save that for next week. If we have different types of beans, and the beans are all managing resource, they're resource manager beans, and we tier them off, then we just, economies of scale, we just add another server, create more bean, you're going to create another bean, or replicate the bean, and it goes to the same database. So we have 10,000 on this bean going to one connection to the database, 10,000 on another bean going to one connection to the database. The concept being that we're minimizing the hit to the simultaneous connections to that database, because this is where the database is going to run slow. If the database is running like a snail, it's running like a snail for all of these people out here. So it's a way of designing the tiering to take into advantage the servlet concept and bringing the servlets into the picture. The client makes a request to the servlet. The servlet communicates with the JSP page and sends a response back to the client. So we put the middleman in here, and we make it so it directly goes to the servlet, and then we can have and the servlet is going to have components in there, and one of those components in this particular example is going to be a Java bean that's going to connect to that database. And the servlet can have multiple different types of components and different types of beans in there too, because servlets are flexible. Servlets can do anything. They just serve up behavior. So a web-based client may make a request directly to the Java Servlet, which actually generates the dynamic contents, wraps the results into a result bean, maybe, and invokes the JSP page. JSP page accesses the dynamic content from the bean, sends the results as HTML to the browser. So this approach creates more reusable components that can be shared between applications and may be implemented as part of a larger application itself as well. So it still has scalability issues in terms of handling connections in terms of the enterprise resources such as the database. There's still some issues with that, and we're going to get into those issues in a few seconds here. Although I am going to end pretty soon because I'm looking at my clock now. I'm not going to make the same mistake I made on Monday. So I just kept going and going and going. I'm like, oh, these people have to leave, don't they? So we got another 15 minutes. I'm going to stop it. I'm going to find a good stopping point. How's that? All right, so scalability, processing with enterprise Java Bean technology. Now, keep in mind, I haven't given you the big picture yet. This is only the first step of it. There's more to this. So don't walk away today. Don't come back next week and discover, oh, wait a minute, there's a missing link. So JSP page can also act as a middle tier with the Java Enterprise Beans, and this is really the missing link that I'm referring to. In this case, the JSP page interacts with back and forth responses via the Enterprise Java Bean component. So the beans are providing the missing link that go into the servlet that provides you the ability to manage those resources. The browser connects to the JSP. Look at that, we have RMI out there. And we also have Corba kind of technologies. And I'll get that in a couple more lectures. I'll talk about this other technology here. But whatever you're using, the RMI is just the request that's going to happen. You can implement this with RMI. You can implement it with other components and technologies. This is middleware. Middleware provides you to connect the JSP with the Enterprise Java Bean. The Enterprise Java Bean is going to do all the work with the resource instead of the JSP. So the Java Bean component manages the access to the back-end resources, which provides scalable performance for high numbers of concurrent users, as the example I just gave you a few minutes ago with the database bean. So for e-commerce and other applications, the Java Enterprise Bean manages transactions and underlying security and simplifies the JSP page itself. So this model will be supported by the Java. It's supported now. It will be. It is supported. The slide set's kind of old. This was what was it was right when it was coming out. Actually, the slide set's about a couple years old. So. But I think this is a good spot because now we're going to get into Model View Controller in terms of putting the components together. So I'm going to stop today on this particular slide, which is slide number 61. So actually I'll probably just look it up. Next week what we're going to do, because if this is the first time you've ever heard of this stuff, it's probably going to be overwhelming actually, because what I'm going to do next is take this and put it on steroids essentially and compartmentalize it out in terms of design patterns and take the logic and separate it out in terms of models to kind of create different types, and I'm kind of just thumbing through the slides. I'm looking for one here at the end. If I can find it. No, it's probably not. Nope, it's not in this lecture. It's in the next one. This lecture goes in well with the next one I'm going to give you. That's going to be servlets on steroids with all of the different web tiers. Because what I haven't shown you is how to put the different items on the different tiers. So the application tier, the persistent tier, containing the components and the beans and the items to make the whole system work together. So I'll stop for today. On slide 61. You can digest this and go home and do the JSP assignment if you want. Actually, it's not too bad. It's a tutorial. It gives you the source code, gives you everything you need to do for it. So it's not difficult. Actually, you don't have to write any code, but you do have to make sure you have the right components installed in order to test it. If you can't test it, don't worry about it. I'm not going to know the difference. You're just going to turn in the pages you created, the HTML, the JSP, and the Java file, the source code file. And I'm not going to ever know if you did it or not, actually. But if you're interested in seeing it work, it's a great eye-opener. Actually, it's enlightening to see it actually work. If you've installed the J2EE, you probably have a server on there, and you probably have it through NetBeans, or you might actually have it through Eclipse. You could probably simulate it with a local server that gets installed. But I'll leave that to you as an activity to experiment with. So. Questions, comments, or concerns? Did you guys get enough for today? I didn't go too long? Okay. We're done. See you next week.